everyone, in this video we're going to examine the kinetic molecular theory of gases and explain gas pressure. So the kinetic molecular theory is really just a description of gas particles and what they're like and how they behave. We can use it to talk about gas particles the proper way, and it helps us explain some of the properties of gases that we observe in real life. There's lots of different versions of this theory, so if you end up Googling it to find out more information, you'll see some different versions. This is just one of those, but most of them have what are called the three basic assumptions. These are the three components of the theory that we'll use to describe what gas particles are like. So after we talk about each of these basic assumptions, I'm going to add that assumption to a particle model of a gas to give us a visual for what these gas particles look like according to the kinetic molecular theory. The first part of the theory says that gas particles are hard spheres, and between them there is empty space. If I start drawing this into my particle model, all I need to do is maybe put three particles of a gas. I'm drawing them as circles to represent the part of the theory that says they are hard spheres. And between these particles there is empty space. So maybe let's just emphasize that component by writing empty space in between the two particles, which means there is nothing there. The second assumption of the theory says that gas particles move rapidly and in straight lines with no attractive forces between them. So these particles are moving around really fast, and that motion is always in straight lines. So to represent this motion, we'll draw in some arrows, and to represent the straight line aspect of it, we'll draw these lines as straight as we possibly can. Now this motion is also extremely fast. I've labeled one of the arrows with 600 miles per hour because some of these particles can go hundreds if not thousands of miles per hour as they zoom around. Let's also add in a fourth particle right next to this one up top. In between these two particles, we're going to label the other component of this assumption that says there are no attractive forces between the particles. This means that anytime two particles get near each other like these two are drawn, there will be no attractive forces between them. And finally, the third assumption of the theory says that collisions between the particles are perfectly elastic. And an elastic collision means that there is no loss in kinetic energy. So I'm going to add one fifth and final particle here, and its motion is going to be drawn towards this other particle so that they will be shown to collide with each other. So after the collision, these two particles are going to bounce off of each other, moving in opposite directions. So maybe this particle goes this way, this particle goes somewhere up this way, but what's important is that the kinetic energy of the particles after the collision in total is exactly the same as it was before. This tells us that gas particles, if they can't ever lose kinetic energy, they will never ever stop moving. So these are our three basic assumptions, and they also make up some of the key ideas for this video, so make sure you take a moment to pause and write them down. Before we move on to talk about gas pressure, here's a slightly more professional version of a particle model showing the particles moving around in straight lines and colliding with each other. Now, once you know about the kinetic theory of gases, you can use it to start to explain things we observe that gases do. One of those things that's really important is called gas pressure. Gas pressure, of course, is what allows us to do things like fill a balloon, inflate a car tire, or shoot a paintball gun. Now, gas pressure is defined as the force exerted by a gas per unit of surface area. And that's kind of a tough definition because this word force is not always super clear to people and exactly what it means. So let's take a moment and look at another particle model to see if we can understand how force plays a role in gas pressure. So in this new container, I've got one gas particle shown down the bottom in blue. If I start that particle moving around the container like gas particles do, you'll notice that it collides with the inside walls of this container. And as it collides with those walls, it pushes against them or exerts a force against them. Much like if you threw a basketball against the inside of a gym wall, the basketball would push against that wall. This gas particle pushes on these walls too. Now, if I didn't have just one particle, if I had two particles both moving and colliding, they would have twice as many collisions, twice as much pushing force, or three particles would have 3 times as much pushing force, or in real life we have thousands, millions, billions, many moles of particles all colliding, pushing on the inside walls of that container. And that force can add up to a lot, and so much that it can do things like inflate a tire and hold up a 2,000-pound car. So this gas pressure is caused by collisions of the gas particles with the inside walls of whatever container they are in. It's also our final key idea for this video. That concludes the video on kinetic molecular theory and gas pressure. Here's a brief summary.